This is a presentation on non-conventional steelmaking routes. In today's session, we will explore how emerging technologies like EAF and hydrogen-based DRI are reshaping the global steel landscape, driven by cost efficiency, environmental mandates, and the urgent push towards green steel. Let's dive into the data and trends that are defining the future of iron and steel production. Like, uh, uh, let's have a look on economic comparison on cost and investment, which is most important part in the this presentation session. So let's begin with the cost comparison across major steel making routes. As of 2024, BF remains the lowest in operating cost at US $390 per ton, while S2DRI EF is the highest at 650 US dollar. However, when we look at investment per ton of capacity, EF stand out as the most economical at just 220 US dollar. This contrast highlights the growing appeal of EAF, especially for rapid capacity expansion. This slide reinforces the investment advantage of EF technology. With the lowest capital requirement among all routes, EF is emerging as the preferred choice for new installations. It offers flexibility, lower emission, and faster deployment compared to blast furnaces, making it ideal for regions aiming to modernize their steel infrastructure. Here we break down the production cost, raw material, and energy, where we see that how each component dominate across all routes. This insight is very crucial. Any effective strategy to reduce steel making cost must address material efficiency and energy optimization, because both are important, and hence it also explains why scrap based EAF are gaining a traction globally. Now coming to the steel production contribution, as you can see that steel production contributes 7 to 11% of global CO2 emissions. Regulatory pressures like European Union CBAM and national net zero targets are reshaping the industry. Technologies like EAF and S2DRI are gaining momentum tremendously. For India, this means preparing for stricter export standards and embracing greener production pathways, and which is a now need of our. So let's look at a global trends. China Bao leads with the BF, while Nucor is fully EAF based. India's Tata, JSW are mixed technologies regionally. The US, Turkey, Brazil, and India are adopting EAF fastest. This shift reflects both regulatory pressure and economic opportunity. Green steel becoming more viable as as future outlook shows. The premium is expected to drop from 210 US dollar per ton in 2024 to just 5 US dollars by 2050. Hydrogen prices are also falling from 4.5 US dollar per kg to towards that we can say around 2 US dollar per kg. So once hydrogen hits around this margin, around this line, that is US dollar 2 US dollar per kg, green steel become globally competitive. India must invest around 120 US dollars billions by 2030 to stay ahead. Now coming to the cost projection, which is supposed to be a very important part. This slide visualizes the declining cost trajectory of hydrogen and green steel. As hydrogen becomes cheaper, green steel production will rival conventional methods. The tipping point is near and early adopters will benefit most from this transition. To conclude, EAF based plants offer the fastest and most cost effective expansion, while BF remains dominating, it faces increasing regulatory and cost challenges. Green steel is becoming economically viable with hydrogen cost as the key driver. For India, a balanced portfolio, conventional, EAF, and green steel is essential for resilience and global competitiveness.